Hi viewers, welcome back to my channel. So in this video, we're going to discuss another AMCAT Automata questions. So this is the next video in the series. We are dealing with a different printing pattern. So I have got a different interesting pattern today. So let's get started. So before getting started, if you think my work is good, please don't forget to like, share and subscribe to my channel. So I've already made few videos in this series, and if you have forgot to watch that, I'll just add it in the I button. Do check that out. So this is the pattern that we're going to deal today. So if you see, this is an alphabetical pattern and we were dealing with the number patterns these days. So it's just a small slight change that we're going to deal with today. And if you see, for input n is equal to 5, we're having a output something like this. A, A, B, A, B, C, B, A. If you see, the alphabets moves in the forward to the first half of the row and then it again moves in the reverse, like A, B, C and then again B, A. So that is the logic that we are going to write today. So pause the video once and try to write the logic for this program, and then we will discuss the logic. I hope everyone got the logic. Now let's discuss the logic. So the first thing that I always suggest whenever we are dealing with patterns is to break it into a table and marking the number of rows and columns to it. So if you mark the number of rows and columns, if you see, we will have around 9 columns and 5 rows for input 5. So if you see, the number of rows and the input value is same. And if you see in my previous videos, we used to use two loops, right? One is for the rows and another is for the columns. In that case, we had a connection between the column and the input value and the rows and the input value. Similarly, if you compare with this question, we have a connection between the rows and the input value, because input value and rows are same, right? So for n is equal to 5, we have the number of rows as 5. So they both are connected. But if you see, the columns here, the columns and rows are not connected. If it were 10 rows, we could have easily connected that. Sorry, 10 columns, we could have easily connected that. But if we have only 9 columns here. So what I'm going to do is I'm going to use 3 loops here. So in the 3 loops, the first loop is going to be the loop for the rows. That remains the same. So if you see, for input n is equal to 5, the first outer loop will be acting for the rows. So we'll be moving between the different rows with the help of the loop 1. So second loop will be for the columns. That is for the first half of the columns. If you see here, I have marked it with a violet triangle. It is just an increasing alphabetical pattern. If you just consider that violet triangle, it is an alphabetical pattern that is increasing A, B, C, then A, B, C, D, A, B, C, D, E. It is a similar pattern that I have printed with the help of the numbers. And so first loop is going to be used only for printing that particular triangle pattern. And then the second loop will be used for printing the excess alphabets that are going to print apart from the triangle pattern. Like I mean, the third character A in the second row and the BA in the third row, CBA in the fourth row and DCBA. That is a decreasing, that is the reverse of alphabets will be printed with a different loop, and the forward of the alphabets will be printed with a different loop. So now we'll try to write the logic for this. So when R is equal to 1 and C is equal to 1, we are having a value, that is A. When R is equal to 1 and C is equal to 2, we are not having any value. Now moving on with the next row. When R is equal to 2 and C is equal to 1, we have the value A here. When R is equal to 2 and C is equal to 2, we have the value as B. When R is equal to 2 and C is equal to 3, we have the value again, and that is A. Now moving on with the third row. When R is equal to 3 and C is equal to 1, we have the value A. When R is equal to 3 and C is equal to 2, we have a value, that is B. When R is equal to 3 and C is equal to 3, we have value C here, that is a new value. When R is equal to 3 and C is equal to 4, we have a value B. When R is equal to 3 and C is equal to 5, we have a value A here. So now let's take these 3 rows. If you consider this violet triangle that I have mentioned in the table, we are not going to consider these values. The first thing is going to be this one will not be considered, this one will not be considered, this one will not be considered, right? So this is going to, and this one will not be considered obviously. So if you see here, I've just denoted them like whatever values that I'm not considering for the loop 2, have just marked it with an arrow mark. If you see here, for n is equal to 5, we are having 5 rows, right? So first we will give the initial value for row. Let us take the initial value of row as 1. If we're giving the initial value for row as 1, then it has to make 5 iterations, because it has to move 5 times. So r is equal to 1, r is equal to 2, 3, 4 and 5. So the condition should be r is less than or equal to 5, or n. In our case, that n or the value 5, that should be here. So that is the condition for the loop 1. So 5 rows. So we are giving it r is less than or equal to the value of n. Now moving on with the next loop. If you see the next loop, that is the inner loop. For the second loop, if you see the triangle is actually increasing, right? So we have to give it as c is equal to 1. Let's take the initial value as 1 itself. If you see here, when r is equal to 1 and c is equal to 1, you have a value a. And if you see the second row, the last value happens when r is equal to 2 and c is equal to 2. And if you see in the third row, the last value happens for that particular triangle is c, and it happens when r is equal to 3 and c is equal to 3. So from this we can know that the last value is happening only when c is equal to the value of r. So you can give the condition as, and if you see here, when the c is less than the value of r also, we have a value, and it stops when c is equal to r. So what we can give it as, c is less than or equal to the value of r. So it starts from 1 and it goes up to the value of row. So if you see here, r is equal to 1 and c is equal to 1, it stops there. Here r is equal to c is equal to, and here it is 3. So this is the condition for the second loop. If you wanted a detailed analysis on this, I have already made a video. I'll just link it in the I button. So first we will implement this logic. So first I will take 3 variables and num, and I will get the value from the user. Let us store this value in num variable. So for the first loop, as we already saw, I will get the condition for r. Okay, let me make this as r and c. For r is equal to 1, r is less than or equal to the value of num, r plus plus. So within this, I will have an inner loop for columns. For c is equal to 1, c is less than or equal to the value of r, c plus plus. We have to print the value. So this value is actually based on the ASCII values that I told before. So if you see, the ASCII value of capital A is 65, as you saw in the ASCII table. So what I will do is percentage %C, comma, I have to give it as C plus 65 minus 1. So you might ask me why I gave minus 1. C is basically, it holds the value as 1, right? We have to print the ASCII value of 65, because the ASCII value of A is 65. So in order to print 65 character, I am giving C plus 65. If I give C plus 65, it will become 66, because 1 plus 65. So I will end up printing 66, that is B. So in order to avoid that, I am giving a minus 1 so that I can print 65. And after this, I will give a /n. So now we will run this program. So let me give it as 3. See, now we got A, AB and ABC. So the violet triangle that we saw in the logic is printed now. So this 65 minus 1, let me explain it one more. If you see, I have to print the ASCII value of 65. That is A. A is the character that will be printed corresponding to the 65 ASCII value. So in order to print that, what I give is C plus 65 minus 1. I have to give C because we have to increment the ASCII value by 1. Then only I can print B and then C. So I have to increment based on a variable. That's why I've added the variable C here. So if I add C plus 65, it become 1 plus 65 and 66, and eventually I'll print B. In order to avoid printing B at first, I'm giving minus 1. So what happens is, first I'll print A, and now again after C is equal to 1, printing A, my C will get incremented to 2. Now if I print now, it will become 2 plus 65, that is 67. 67 minus 1 is 66. Now I will print B, and again C will get incremented, and it will check condition according to the row, and it will print C for the third row. So this minus 1 is to nullify the value of 1 that I have given for the C. So when considering the logic for the loop 3, if you see here, for the first row, we don't need to print any value. That is, I'm talking corresponding to the loop 3. If you see here, there is no extra value to be printed. For row 2, if you see here, we have only one value, and that is A. Like similarly, for row 3, we have two values. For row 4, we have three values, that is C, B and A. And for row 5, we have four values. So this 0, let me make this no as 0, because we're not going to print any value. So the 0, 1, 2, 3, 4 is going to be the looping variable values. So for any loop, we will have looping variable, right? So that value is being holded one. That variable is going to hold this 1, 2, 3, 4, 5. And if you see here, the connection between that value and R is, this value is 1 less than the value of row. If this variable is 0, then R is 1. If this is 1, then R is going to be 2. So from this, what I can give, that the initial value of the looping variable, let me assume that as K is equal to R minus 1, because see, it is 0 and this is going to be 1. So 1 minus 1 will give me 0. So that is going to be the initial value of K. And if you see here, this value should be greater than 1 in order to print. If you see here, the first row, we should not print any value in that first row corresponding to the loop 3. So in order to maintain that, what I'm going to do is K is greater than or equal to 1. Whenever when the K is greater than 1, I have to print. So if I give this condition, then it will print only for the row 2, row 3, row 4 and row 5, because K will hold the value 0 when R is equal to 1, and obviously this condition will fail and no value will be printed. And next is the updation of this looping variable. If you see here, for the row 1, we will have only one value K, that is 1 minus 1, 0, and the 0 is not greater than or equal to the value of 1, and that loop will break. But when you're considering for the loop row 2, we will have the value as 1. 2 minus 1, 1 will be the initial value of the K, and this 1 is greater than 1, and again that value, that is the A value, will be printed for us. After this, the value should be decremented, because I have given the condition as K must be greater than 1. If I am going to increment it, obviously after the 1 value, that is value of 0, the value, the condition will be satisfied. If I am giving K plus plus for the row 2, the initial value of K will be 2 minus 1, 1. If I am giving K plus plus, that 1 will become 2, and it will obviously satisfy the condition K is greater than or equal to 1, because 2 will be greater than or equal to 1, and obviously the next values that I am going to increment for the value of K will get satisfied. So in order to break the loop, what I am going to give is K minus minus. If I am going to give this, then obviously at a certain condition, the value of K will drop to 0, and my condition will fail, that is K is greater than or equal to 1, and my loop will break. Now let's do the coding part. So after this, I'm going to add another loop inside that. So now let me introduce a variable called K first. For K is equal to row minus 1, because it's going to have a variable value less than 1 less than the row value, and then K is greater than or equal to 1, and then k minus minus, printf percentage c comma k plus 65 minus 1. Now I will run this. Enter number, let me give 5. If you see here, you got the output A, so this first part of the output we already got, and this A, BA and CBA, DCBA we got it with the second loop. So I gave the value as k greater than or equal to 1 because obviously the value of row will go on increasing as the number of rows increase. So we have to break the loop at some point of time. So since I have given as k greater than or equal to 1, I can't give k plus plus. If I give k plus plus, obviously as values increases, it will be greater than 1. So in order to avoid that, I have given k minus minus. So now we'll just see the logic for this. When r is equal to 1, our value of k will be 1 minus 1, that is 0, and our condition will fail, and so no output for that. And next, this loop will break and r will become 2. When r is equal to 2, the initial value of k will be 2 minus 1 1, and our condition will be satisfied. So what happens is we will print k plus 65 minus 1, that is 1 plus 65 is 66 minus 1, again it is 65. So the ASCII value that is corresponding to 65 is A, so A will be printed, and after this k will become k minus minus. If it becomes k minus minus, k will become 0, and obviously the condition is not satisfied, that is k is not greater than 1, and again no output is available. Now after this r will become 3. When r is equal to 3, our k value, initial k value will be 3 minus 1, that is 2, and if you see here it will go into the loop because k2 is greater than or equal to 1, and we will print 2 plus 65 minus 1, that is 67 minus 1, 66, and so the ASCII value of the character corresponding to 66 is B, so B will be printed, and again k will become minus minus, so our k value will become 1, and 1 is greater than or equal to 1. So again if it goes inside, it will print 1 plus 65 minus 1, that is 65, that is A. So if you see here, that's why we have first B printed and then A printed. Okay, so after this, when R is equal to 4, the initial value of k will be 3, and if the condition will be satisfied, 3 is greater than or equal to 1, so 3 plus 65 minus 1, so that will be 68 minus 1, 67, so C will be printed, again k will decrease to 2, and B will be printed because the condition will be satisfied, and k is equal to 1 and A will be printed, and that's why we have CBA in the row 4. So ABCD will be printed with that loop, upper loop, C loop, and this CBA will be printed with this K loop. So now when r is equal to 5, the initial value of k will be 4, and if you see 4 plus 65 is 69 minus 1 is 68, that will correspond to D, and again k will become minus minus, k will become 3, and 3 is greater than or equal to 1 again, so we'll print C, and then k will decrement to 2, we will print B, and again k will decrement to 1 and it will print A, and that's why we have DCBA in the reverse order. So hope everyone enjoyed this video. So if you think my work is good, please don't forget to like, share and subscribe to my channel.